Dear students, in this lecture you are going to learn the remaining two differentiations or the methods of differentiations. There are parametric differentiations and implicit differentiations. Now, so first we will see the parametric differentiations. So here the parametric curves like if f of x is or x equals to f of t, and so y equals to g of t. Here x and y are functions in terms of t. Then the derivative of y with respect to x means dy by dx is equals to dy by dt whole divided by dx by dt. So here we need to find the derivative of y with respect to x, but the given functions are in terms of t. X is in terms of t and y is in terms of t, but the derivative of y with respect to x is dy by dt whole divided by dx by dt, or simply you can write this as z prime of t divided by f prime of t also. So this is called the parametric differentiation. So we'll see how it will be exist. For example, if x equals to cos t and y equal to sin t, then find dy by dx. So here two functions are given, x in terms of t and y is in terms of t. Now sure, the parametric differentiation for this problem, so that is here x is given, x equals to cos of t and y equals to sin of t, and you know the derivative of this x with respect to t, that means dx by dt. So dx by dt, this is equals to d by dt of cos t. So what is the derivative of cos t? This is minus sin t. Now, so then differentiate this y with respect to t, that is dy by dt is, so the derivative of sin t is cos t. Now here we need to find the derivative of y with respect to x, right? So that means dy by dx. But we have a dx by dt and dy by dt. So dy by dx, that can be written as dy by dt whole divided by dx by dt. Now, so what is dy by dt? That is cos t whole divided by minus sin t. So which is equals to, now cos t divided by minus sin t, that is minus cos by sin is nothing but cot. So this is cot t. So the derivative of y with respect to x is minus cot t. X is cos t, y is sin t. So let us take one more example. Now if x is e power t plus 1 and y is e power minus t plus 1, then find dy by dx. Now, so here x is given, so differentiate this x with respect to t, that is dx by dt, now which is equals to d by dt of e to the power of t plus 1. So derivative of e power t, that is e to the power of t, derivative of 1 is a constant, therefore 0. So dx by dt value is e power t, and here y is e power minus t plus 1 is given, so therefore dy by dt, this is derivative of e to the power of minus t plus 1. Now, so which is e to the power of minus t derivative is e power minus t into minus 1, right? With respect to t, you need to apply for minus t, so it is minus 1, plus derivative of 1 is 0. So finally this is minus e to the power of minus t. Now, so dy by dt is e to the minus e power minus t, but so we need to find the derivative of y with respect to x. So this is the dy by dt divided by dx by dt, that means minus e power minus t divided by e power t. Here we can write it as minus e to the power of minus t into e power minus t. See, this is e power t, we can express it as e power minus t. So finally minus e to the power of minus 2t. So the derivative of this is minus e power minus 2t. Example 3, if x is a logarithm of t plus sin t and y is e power t plus cos t, then find the derivative of y with respect to x, or dy by dx. So first, so we need to find the derivative of x with respect to t, that is dx by dt, now which is equals to log of t. So derivative of log t is 1 by t, right? Means you know, d by dx of log x, 1 by x, but it is with respect to t, so 1 by t. Derivative of sin t is cos t. Okay, next here y, so dy by dt evaluated. Dy by dt means you need to differentiate this y with respect to t. So e power t derivative is e power t. Now cos t derivative is minus sin t. Now so we have a derivative of x and derivative of y with respect to t. Now we have a dy by dx, right? So dy by dx, which is equals to dy by dt whole divided by dx by dt. Now so replace these two values from this. So dy by dt means it is e to the power of t minus sin t whole divided by 1 by t plus cos t. You can simplify this. So it is e to the power of t minus sin t divided by say this is 1 plus cos t into t by t, or you can write it as a t into e to the power of t minus sin t divided by 1 plus t into cos t. So this is the derivative of y with respect to x. Now say the fourth example, if x equals to 380 by 1 plus t cube and y is 380 square by 1 plus t cube, so then find dy by dx. So here we need to find the derivative of y with respect to x. So first differentiate x with respect to t, and next differentiate y with respect to t. Afterwards you can evaluate dy by dx by the parametric differentiation. Now so here dx by dt, so we need to apply the derivative for this x with respect to t. So here x is a function of t, it is in the form of rational p by q form. So you know the differentiation for rational functions, right? U by v form. Now so u by v form in the, so this is v into derivative of d by dt of u, so it is 380 minus 380 into derivative of 1 plus t cube, t by dt of 1 plus t cube whole divided by 1 plus t cube whole square, right? So it is v into derivative of u minus the u into derivative of v divided by v square. Now so this is 1 plus t cube, 1 plus t cube into derivative of this is 3a minus 380 into derivative of 1 plus t cube, this is 3t square whole divided by 1 plus t cube whole square. So this is which is equals to a 1 into 3a, that is 3a plus 3a t cube minus 3 into 3, so it is 9 into a into t to the power of 3 divided by 1 plus t cube whole square. Now so finally this is 3a minus, so 3 minus 9, so this is minus 6a t cube divided by 1 plus t cube whole square, right? So dx by dt value is this one. Next dy by dt evaluated. So dy by dt, again it is a rational function, right? Again it is a rational function, so apply the derivative using quotient formula. So this is 1 plus t cube into derivative of this 3a constant, so derivative of t square is 2t, so finally this is 680, right? Derivative of this is 680 minus 3a square into derivative of v, derivative of v అవుతుంది 0 plus 3t square divided by 1 plus t cube whole square. Now, so simplify this. So 680 into 1, this is 680 plus 6a t to the power of 4 minus 3at square into 3t square. So this is minus 9a t to the power of 4 divided by 1 plus t cube whole square. Now, so finally this is 680 minus 3a into t to the power of 4 whole divided by 1 plus t cube whole square. Now, so we have a derivative of x and y with respect to t. So derivative of x with respect to t is this one. Derivative of y with respect to t is so this. But here we need to find the dy by dx, right? So dy by dx is equals to, now so this is a dy by dt by dx by dt. Now, so replace these two values from this. Now, so this is the 680 minus 380 power 4 by 1 plus t cube whole square. In the denominator, both are having the same term. So therefore, direct it is cancelled out. So just you can write it as 680 minus 3a into t to the power of 4 divided by 3a minus 6a t to t cube. Right? 1 plus t cube whole square, 1 plus t cube whole square, cancel this again. Now in the numerator, what is common? So 3a is common and t also common. So then this is 3at times of 380 common is ankondi. Then the remaining part is 2 minus t cube by here in the denominator. So 3a, so 3a is common. 3a times of, so it is 1 minus 2t cube. So this is 3a and 3a gets cancelled. Now, so the remaining part is t into 2 minus t cube by 1 minus 2t cube. So here the derivative is this part. So clear observation. So to find the dy by dx for this type of functions, so evaluate derivative of x with respect to t and derivative of y with respect to t and replace. So we will get like this. So the fifth problem, differentiate f of x equal to e to the power of sin x with respect to g of x equal to sin x. Means you need to find the derivative of f with respect to g, right? So here we know the derivative of y with respect to x means it is dy by dx. Here see the question, differentiate this function with respect to g means it is dg by dx, sorry, dg by df dg by df. Differentiate of f with respect to g means dg divided by df. And both f and g are in terms of x. So individually you can differentiate both with respect to x. So final thing is here df by dg by df. Sorry, here differentiate f with respect to g kada and df by dg avutundi. So here we need to compute what we have to compute. According to the question, we have to compute or we have to evaluate f with respect to g. So it is df by dg. So df by dg and find out. So df by dg. So divide the numerator and denominator to the dx. Therefore it is df by df by dx whole divided by dg by dx. Right? Now, so we have the functions f of x. F of x equals to e to the power of sin x. Right? So the derivative of this implies derivative of f with respect to x e to the power of sin x derivative. E power sin x derivative is e power sin x into derivative of inner function means it is sin x. Right? Now, so finally it is e to the power of sin x into derivative of sin x is cos x. So f of x derivative find this. And we have one more function, that is g of x. This is sin x. Now, so this implies, so apply the derivative of g with respect to x, means it is dg by dx, right? Now, so dg by dx is sin x derivative cos x. So finally df by dg. Now, so you can evaluate df by dg, or f prime of x divided by g prime of x. So df by dg, which is equals to df by dx whole divided by dg by dx. Then df by dx is e to the power of sin x into cos x divided by cos x. So here cos x and cos x gets cancelled. Finally it is e to the power of sin x. So find the derivative of f of x, that is x to the power of sin inverse x with respect to g of x equal to sin inverse of x. So find the derivative of f with respect to g. Again it is df by dg. So here we have to find df by dg. So before that we need to have the derivative of f and g. So better evaluate the derivative of f and derivative of g, then finally it is df by dg. See, we know how to evaluate the derivative for this type of functions from previous class, x to the power of sin inverse x. Now how to evaluate this? So f of x equals to x to the power of sin inverse of x. Sin inverse of x means we need to apply logarithm on both sides. So log of f of x, which is equals to, now what will happen? So it is a sin inverse of x into log x, right? It is log of x to the power of sin inverse x, means sin inverse of x into log x. Now so apply the derivative. Now so if we differentiate this, so it is log x form, so that is 1 by x, x means 1 by f of x into derivative of f of x value, so that is df by dx. Since f is a function of x, so compulsory, so there exists an inner function, so that we need to apply the derivative of f. Now so u into v formally, so sin inverse of x into derivative of log x is 1 by x plus log x into derivative of sin inverse x is 1 divided by root of 1 minus x square. Okay, so finally this is f of x into, here f of x into, then it's cross multiplication now, df by dx equals to this. So sin inverse of x by x plus log x by root of 1 minus x square. Okay, here f of x is nothing but given function, that is x power sin inverse of x. And g of x is also given, right? See, here you can write g of x. So what is g of x? G of x is nothing but sin inverse of x. So dg by dx ఏమవుతుంది? dg by dx is 1 divided by root of 1 minus x square. Okay, now we have this f df by dx and dg by dx. So df by dg, which is equals to df by dx by dg by dx. Now df by dx is nothing but, so this f of x into sin inverse of x by x plus log x by root of 1 minus x square. Now whole divided by 1 divided by root of 1 minus x square. Since dg by dx, right? dg by dx equal to 1 by root of 1 minus x square. Now so finally this is f of x, or 1 by root of 1 minus x square can be written as root of 1 minus x square. Numerator తీసుకొచ్చేసాను. Into f of x is there. f of x is nothing but x power sin inverse of x into this part is as it is. That means sin inverse of x by x plus log x by root of 1 minus x square. Okay, so this 1 by root of 1 minus x, root of 1 minus x kani ikkada numerator తీసుకొచ్చేసాను. This is like a by b all divided by c by d. So means it is a d by c form, right? So this is So the next method of differentiation which is implicit differentiation. An equation of the form f of x comma y equal to 0 which is defined in r square or xy plane. So that can be put in the form of y equal to f of x is known as explicit form. Otherwise it is implicit form. So means f of x comma y equal to 0 can be expressed as y equal to f of x is explicit, otherwise implicit, right? Y equal to f of x equation ఈ ఫార్ములా కన్వర్ట్ చేసి దాన్ని ఎక్స్ప్లిసిట్ ఫామ్ అంటాం. ఓకే, మనం ఎన్ని రోజులు ఫంక్షన్స్లో చేసినవన్నీ కూడా ఎక్స్ప్లిసిట్ ఫార్మ్స్. Then the function that cannot be separate y in terms of x is an implicit function. So now we need to apply the derivative for that type of functions. So for example, here x square minus 6xy plus y square is equals to 0. See, here we cannot separate y and in terms of x here. So since 6xy plus y square is there, then so this is known as implicit form. Here we know x square plus x minus y equal to 0 unnakondi. So here we can express this as implicit form, right? So we can, so this is nothing but implicit, sorry, it is implicit form. Y means we cannot separate y in term y equal to f of x form. Here we can separate this, so y equals to x square plus x, so therefore this is known as explicit form. Final definition lo ade undi. Okay na, f of x comma y equal to 0 can be written as y equal to f of x is explicit, otherwise implicit. ఇలా రాయగలిగాం అనుకోండి దాన్ని అంటారు explicit, otherwise implicit. Now so we know the derivatives for explicit functions. Previously చేసినవి కూడా explicit functions. Now so we need to apply the derivative for this type of equations or implicit forms. So for example, see the example, if the equation like x square plus y square minus x equal to 0, then find dy by dx, right? So it shows whether it is explicit or implicit. So try to find the derivative of the given equation. Okay, it seems like an explicit function, right? Since we can separate y square in terms of x, so no issue. So first of all, apply the derivative for this. Now, so differentiate on both sides with respect to x for this, so that it is dy by dx of, now it is x square plus y square minus x equals to dy by dx of 0. Now, so this is now dy by dx of x square, that is 2x, plus derivative of y square means it is 2 into y, but y is always in terms of x, right? So y is a function of x, so we need to apply the derivative of that unknown function, hence it is dy by dx. If it is y, compulsory it is y is in terms of x, minus the derivative of x is 1, so which is equal to derivative of 0 is 0. Now so we need to separate dy by dx from this. So if we separate dy by dx, so this is 2y into dy by dx, which is equals to 1 minus 2x, right? 1 is positive and 2x will be the negative. So finally dy by dx is equals to 1 minus 2x divided by 2y. So this is the derivative of that function. So this is obviously explicit differentiation only. So whereas in implicit functions, so in order to differentiate implicit functions, so we differentiate f of x comma y equal to 0 with respect to x. So where you need to treat y as a function of x compulsory. Here y ni x lo treat chesam kada, so implicit differentiation chesinapudu compulsory. So you need to treat this y in terms of y as a function of x, and afterwards equate it to 0, then separate dy by dx from the equation. So dy by dx ని సపరేట్ చేస్తే మనకి అందులో dy by dx వాల్యూ ఏంటో తెలిసిపోతుంది. Now see this problem. If 2x square minus 3xy plus y square plus x plus 2y minus 8 equal to 0, it is in the form of f of x comma y equal to 0. So can we separate y in terms of x? No. So there are so here y is involved with x. The combination of x and y will be there. So we cannot separate the y from this. So this is known as implicit form. Now we need to find the derivative for this function. Means dy by dx. So first of all, what you have to do? So you need to differentiate this entire equation and treat y as a function of x and equate it to 0. Already 0 ki equate chesina. Then so after the differentiation, you need to separate the derivative of y with respect to x. Now, so apply the derivative on both sides. So this is derivative means d by dx of 2x square minus 3xy plus y square plus x plus 2y minus 8. So which is equals to the derivative of x, derivative of 0 with respect to x. Now derivative of 2x square. Derivative of 2x square means 2 into x square derivative is 2x minus 3 into derivative of xy. So here so it is u into v method, right? Since y is you need to treat y as a function of x. So apply the derivative of x into y plus derivative of y square means 2 into y into derivative of y plus derivative of x is 1 plus derivative of 2y is 2 into dy by dx minus derivative of 8 is 0, which is equals to 0 since the derivative of 0 is 0. Now so this implies, so it is our 4x minus 3 times of, so u into dy by dx, so it is x into dy by dx plus y into derivative of x here, right? U into dv by dx plus v into du by dx, right? So v into derivative of x is 1 plus 2y into dy by dx as it is plus 1 plus 2 into dy by dx. So already 0 ki equation. Now we need to separate dy by dx from this. Now so before that, so this is 4x minus 3x into dy by dx minus 3 into y, 3y plus 2y into dy by dx plus 1 plus 2 into dy by dx is 0. Now so this is 4x minus 3y without dy by dx terms first one, 4x minus 3y plus 1. Now so then the transposition at right hand side composition. So this is, so 3x plus, sorry, transposition is minus, so this is positive and it is negative, and 2 dy by dx also negative, minus 2. So 3x minus 2y minus 2 into dy by dx. Now so finally dy by dx equals to, so this is the 4x minus 3y plus 1 divided by 3x minus 2y minus 2. So the derivative of this with respect to x is, or you can write so minus common this way, or we can express this as 3y minus 4x minus 1 divided by, but the positive होते हैं negative होते हैं. So like it is 2y minus 3x plus 2. Both the things are same. So third one, if x into sin y plus y square minus 1 equals to 0, then find the derivative for this function or dy by dx. Now see the solution. So it is a implicit function, so that we need to apply implicit differentiation. Now derivative of x into sin y, it is a uv rule, right? Now derivative of, like it is x into d by dx of sin y plus sin y into d by dx of x, means it is 1, plus derivative of y square is 2y into dy by dx minus derivative of 1 is 0, so which is equals to derivative of 0 is 0. Now so from here so we can separate dy by dx. No, for first of all you need to evaluate the derivative for this. So x into sin y derivative is cos y into inner function is y, right? So you need to treat y as a function of x, so that we need to apply the derivative for that unknown function dy by dx plus sin y plus 2y into dy by dx. Sorry, dy by dx equals to 0. So final simplification. So this is dy by dx is equals to, right answer is dy by dx, so which is equals to minus sin y divided by 2y plus x into cos y. So simply, student, so that is the answer, minus sin y divided by 2y plus x into cos y. See here from these two terms, so dy by dx is common, sin y na transposition minus sin y. Next you need to divide with that 2y plus x into cos y. Now if x power 4 plus y power 4 minus a square into xy is 0, then find dy by dx. Here x comma y are variables and a is a constant. Now apply the derivative, so that it is a 4x cube plus 4y cube into y is a function of x, so that dy by dx minus a square is constant into derivative of u into v, so x into dy by dx plus y into derivative of x is 1, which is equals to 0. Now this implies, so 4x cube plus 4y cube into dy by dx, now minus a square into x into dy by dx minus a square into y is 0, minus a square into y is 0. Now say separate dy by dx here, so that it is dy by dx times of 4y cube minus a square into x. Now so which is equals to, now say without dy by dx terms of these two, a square y and 4x cube. Now so you can transport to right side, that is a square into y minus 4x cube. Now so finally dy by dx, dy by dx which is equals to a square y minus 4x cube whole divided by 4 into y cube minus a square into x. So finally the derivative for this from the implicit function or implicit form is this one. Now the last problem, if y equals to x to the power of y, then find dy by dx. So it is obviously implicit function, but the two variables are there, like logarithmic differentiation. So for this we need to apply logarithm compulsory. So better apply the logarithm on both sides. So taking logarithm on both sides for the given function, so it is log y is equals to, now so it will be y into log x, right? Now apply the derivative on both sides with respect to x. So this is the derivative of log y is 1 by y into, here you need to treat y as a function of x, so that it is dy by dx. Here it is u into v form. So y into derivative of log x is 1 by x plus log x into derivative of y is dy by dx. Now so separate dy by dx terms, so that it is, see it is 1 by y, then it transposition on, so it is minus log x into dy by dx. So this is y by x only, y into 1 by x is y by x. Now this implies dy by dx is equals to y by x into, here we can write this as y divided by 1 minus y log x. See this is 1 by y minus log x. Here simplify. So this is actually 1 minus y into log x by y into dy by dx. which is equals to y by x. దీని సింప్లిఫై ఈ ఫార్ములాకి వచ్చేసింది. Now dy by dx equals to y by x is as it is. Now this can be written as reciprocal. So y divided by 1 minus y into log x. So finally the derivative means dy by dx is equals to y square divided by x times of 1 minus y into log x. This is the derivative for this y equals to x to the power of 5. So dear students, so I hope you understand these two methods also. So do solve the problems from exercise 9c. At least some of the problems related to these 4 methods. So in the next lecture we'll see the exercise problems. Thank you.